Today we're going to be talking about angle bisectors. So I have open a blank GeoGebra file, and we're going to start by constructing an angle. And we're going to construct it, let's say a 70-degree angle, opening clockwise. And to complete the angle construction, we do need to construct our sides, which are raised to our angle. Okay? And as I said, we're talking about angle bisectors, so I also want to construct an angle bisector. Now, we can verify that it's an angle bisector by placing a point on the bisector itself, okay? And then we are going to construct the angle there, and it will tell us how many degrees our angle is. Okay, so let me just move these numbers out of the way. So we have our original angle 70 degrees, and now we can see that half of 70 is 35. So yes, this angle is in fact bisected, okay? Now, there is a relationship between the point on the angle bisector with the sides of the angle. Okay? So before we can actually talk about that relationship, which is going to be the angle bisector theorem, I do want to just bring up a definition, which is distance. Okay? So copy this down in your notebook. The distance from a point to a line is the length of the perpendicular segment from the point to the line. So copy that down. So back in my file, here's what this means. I have a point. I want to look at the distance from this point on the angle bisector to the side of the angle. Now, to measure a distance, it's using the perpendicular segment from the point, which is on our angle bisector, to the line, which is our side of the angle. So we need to construct a perpendicular line from this point to the side of the angle. Okay? And what we can do is we could actually place or construct a segment on top. Now we know that this segment is perpendicular to the side of the triangle. That's what we just showed, right? I actually want to put a point on the perpendicular here, the intersection. Now let's draw this segment in. Okay. And we could find the length of this segment. Okay, so let's find the length of this segment. Length is under here. From here to here, okay? So the length from the point on the angle bisector to this side of our angle is 3.38, and this is in centimeters, I believe. And we could do the same thing with the other side. So let's construct a perpendicular line from our angle bisector point to the side of the angle. Okay, so there's your perpendicular line. We're going to construct a segment on top. So to do that, I need the point of intersection. And let's construct our segment. There we have it. And we're going to measure it. Okay. You'll notice something. What do you notice? It's kind of blaring out at us, right? These are the same distances. Now what happens when I move this point, my C? Notice what happens. As I'm moving C, which is the point on the angle bisector, the distance that this point is to the sides of the angle is staying the same. Now remember, these distances are perpendicular segments. Okay, so I could actually, now that I know I drew in my segment, I could delete, oh, no I can't. Okay, let's not delete that. I wonder if we could hide it. Is there an option to hide? Did I miss it? Hide object. There we go. And let's hide this guy. Hide it, there it is. Okay, now it makes things a little easier to look at here. So there's my perpendiculars. Look at that, same distance from each side. That is a demonstration of the angle bisector theorem. Okay, so the angle bisector theorem, let's bring up the angle bisector theorem. Boom, right there. Copy the angle bisector theorem and its converse into your notebook.